No.
Hey, hello. So, welcome all of you in our webinar about our low voltage systems. So, we'll talk about our inverters, Jupiter, Mars, and of course the batteries for these low voltage inverters. I will give you a quick presentation about our products. Then we'll go through installing these products. I will tell you more about how to do this and what problem you can face during installing our products. And after this, I will have the quick, maybe not quick, we'll have the Q&A session. So if you will have any questions, don't ask them during this presentation because I will not read the chat. Just wait till the end, and after my presentation we'll have Q&A session. Then I will answer all your questions. So we'll start. So we'll start from our inverter. So as I said, Jupiter and Mars quite similar. So Jupiter is single phase inverter, Mars triple phase inverter. All settings or installation things we are doing quite the same. So Jupiter from 5 to 10 kilowatt, Mars is from 5 to 14 kilowatt. We'll talk more about Mars, but the same things we can do in Jupiter. So what about advantages of our hybrid inverters? First of all, the 100% unbalanced output. So we can have maximum 5 kilowatt per phase for all inverters. So no matter the power, we have 5 kilowatt per phase unbalanced output. We can connect parallel up to 20 pieces, that's for off-grid mode, and we can have 6 pieces in on-grid. We support a smart load, so we can connect any load. We add some conditions when this load we want to supply or we don't want to supply, and inverter will manage this. To connect our inverter to the grid, to the load, we just have connectors, simple plug and play, so you just wire the connector and easily put it inside inverter. 5 or 7 inches touch LCD screen, 5 inches for Jupiter, 7 inches for Mars. For battery, we can go with auto mode, but also we can go with 9 times settings, 9 times curve settings. So we set some time ranges during the day, and the inverter will follow these rules. And for the PV side, we can go with 150 more oversized the PV side for 150 of inverter rated power. So for example, for Mars 10, we can connect 15 kilowatt of peak in PV side. If we look at the bottom of our inverter, we'll have the grid port. So we connect the grid and the grid load from this side. We have the load when we connect the backup load. So all the EPS load, this load is supported on grid and off grid also. And this GAN port is combined port. We can connect the GAN set, we can connect the smart load, and also we can connect another on-grid installation, so we can do the AC coupling. We have 2 separate PV outputs. So we have 2 MPPT points. For Mars, we have, for first MPPT point, we have 2 inputs. For the second, we have 1. For Jupiter, we have 2 plus 2, so 2 inputs for each MPPT point. At the middle, under this cover, we have all communication ports or communication boards. And on the right, we have battery port and Wi-Fi stick, also with the cover to support the IP65, of course. If we speak about hybrid inverter, we have 2 modes. So we have on-grid mode. In on-grid mode, we have the on-grid home load. So we have the grid, on-grid home load, and we can support the backup load. Also for the GAN port, we can connect smart load, or we can connect on-grid inverter. So we can do AC coupling. We can also connect the GAN set, but it will not work in on-grid mode. So in on-grid mode, we have grid. In off-grid mode, we'll have the GAN set, but it can be connected. Just inverter will not take power from this GAN set. So that's easy. When the grid is off, inverter will switch from on-grid to off-grid in less than 5 milliseconds. So basically, nobody will notice, no light will blink. So that's very fast. And if we go to off-grid mode, in off-grid mode, of course, we don't have grid, so we cannot support the on-grid home load. That's all, the load is off. We have the backup load, of course, and we have the smart load, and we can have the genset. So genset can work and charge the battery, can support the backup load, battery support the backup load, and the system look like this. So less than 5 milliseconds, and we are working this way. Again, when the grid will come back, inverter will try to connect to the grid and automatically start working with the grid and support this on-grid home load. For the Jupiter and Mars, as I said, we can connect them parallel. So 6 inverters in on-grid mode, 20 inverters in off-grid mode. So maximum on-grid power is 84 kilowatts. So we calculate it's like Mars 14 is the maximum power, multiplied by 6, so 84 kilowatt, and 20 inverters, so we can have off-grid installation with 280 kilowatts. About how to connect this parallel, I will tell you later. Remote monitoring for our inverter. So we connect this through Wi-Fi stick. We connect this to our platform. So we use the PV Pro app or online web platform pvintelas.com. Both very similar. They use the same data. We can do the same thing. So we can see, view all the installation, monitor it, and we can change all the parameters through this applications. So we don't have to be on site. We don't have to have access to the LCD screen. We can do this through the mobile app, or we can do this on this web platform. And if we are going to batteries, so we have Jupiter and Mars, and for these inverters, we have battery packs. So we have basically 3 series of battery packs. We have Moon, we have CE48, and we have Link. About Moon, we have Moon, then we have the capacity. So for example, Moon 5 is 5 kilowatt hour battery. Then type of mounting. So R stands for rack mounted, W stands for wall mounted, and G stands for ground mounted. So we have W, R, or G. And Moon is IP21. These batteries have LCD screen. These batteries have Bluetooth. So we also can connect to these batteries to Bluetooth. We have C48 series, 100 and 200, 5 and 10 kilowatt hour batteries. These batteries are IP65. So we can basically mount them in any wet room and wet conditions, can mount outside. Of course, we have to take care about temperature because batteries cannot fully work in below 0 degrees. And we have Link 5, 10, 15, or 20. Link is the battery when we put footer, then we put up to 4 battery packs and the connection box at the top. So we can do like from 5 to 20 Link like this. And all the batteries, any of these batteries, we can connect up to 15 in parallel. Of course, one battery. So for example, Moon 16, we can connect 15 Moon 16s parallel to one inverter. And for the batteries, we use 2 different software. So we use JBD software and we use CN Energy software. That's easy to remember. For batteries with the screen, with Bluetooth, we use CN Energy. For all the other without this, we use JBD software. And if we're speaking about the software, we are speaking also about the application which we use to manage these batteries. So for JBD, we have application in JBD, and for CN Energy is battery monitor, or for the phone is ENBMS. So as I said, these batteries have Bluetooth, so we can download the ENBMS on our phone and we can connect to battery through Bluetooth. If we have batteries with JBD software, if we want to change any parameter, if we want to change communication protocol and we want to connect our inverter to our battery to any other brand inverter and we have to change protocol, we have to connect to this battery with our PC. For CN Energy batteries, we don't have to do this. We can do this through battery monitor, but also we can do this through ENBMS, so connect through Bluetooth, or we can change this on a battery screen. So no need any app. We just change the communication protocol through the screen of the battery. Of course, we have the compatibility list. So we have the list for our inverters and we have a list for our batteries. So our batteries are compatible with any other brand inverters, and our inverters are compatible with other brand batteries. On this list, we have only batteries and inverters which we check by ourselves. So if something is on this list, we know it's working with our product, and we guarantee that it will work correct. And now I want to show you video, and I want to tell you more about how to install our inverters. This video is of course on our Chisage ISS YouTube channel, so you can see this whole video, and here I just take some parts of this video to show you the most important things about how to install Mars and how to install our batteries. So we will start from what tools we need and what's inside the box of the inverter. Okay, so of course, with the screwdriver, we need an electrical drills and the wrench and the clamps. And what we have in the box? In the box, of course, we have inverter, we have the cities, we have the warranty terms, user manual, we have the Wi-Fi stick, wall-mounted bracket, so all the certification screws, cables for parallel connection, all the connectors, so PV connectors, grid, load, GAN connectors, all these things are inside the box. So first thing is to mount our inverter on the wall. So we have to mount this wall mount bracket. We put it on the wall. This second part of this we connect to inverter and then put one on another and make sure that these screws are tight. And that's important part. We have to make sure that our inverter have a space for the heat dissipation. So we have to have like half meter each way, so left, right, top and the bottom, and in front of inverter, so half meter each way, to make sure that inverter will not cheat too much. Also, you have to make sure that the room where you install inverter have good ventilation. Sometimes this electrical room with any other devices, so then can be hot. So you have to remember about a good ventilation for this room. And the next step for installing our inverters is to do the wiring. So if we go to wiring, first thing we will do will be to connect the PV side. So we will put the connectors on our wires and then put these connectors inside our inverter to the input. We have two separate MPPT points, as I say. So one we marked on inverter as PV1, another one as PV2. First one for Mars have two inputs, second one have one. For all of these, maximum voltage is 700 you can put. So for PV1, you can put two strings with 700 input. For the second one, only one string with 700 input. Of course, the current for the PV1, so for MPPT1, is higher than for MPP2. It's changed between Mars and Jupiter, so to make sure it's okay, you have to check with our datasheet. When we wiring the PV, we go to the grid connection. So we have the grid connector, and we wiring them and then put it inside the inverter. Make sure that you have the correct phase order. So phase 1, 2, and 3. Now we have the yellow, green, and red on this video. So make sure that it's correct phase sequence. And then when we will install cities, we have to cover this the same way. And here we have the AC board. So the circuit breaker we recommend is at least 32 amps. We have the 5 kilowatt unbalanced output. So minimum, it can be around 26 amps, 27 maximum. So 32 is the minimum circuit breaker for our inverters to work correct. And then GAN connection. For the GAN connection, same way. So we're wiring the connector and then put into inverter. For our Mars, so for triple phase, for battery connection, we just have to take out these two covers, put the battery power cables, so positive and negative, to the positive and negative port, and the communication cable to the first port on the left. It's marked as BMS, so we put the communication cable for battery to BMS port, put these covers back, and the battery is connected correctly. So only these three cables and the battery should work correct. Then we go to city connection. So in our box, we include the cities. So we connect 3 cities in our Mars and triple phase inverter. Make sure that the phases are correct. So city number 1 to the phase number 1 and to ports 27, 28. Then we go to city number 2, of course, arrow to inverter. So make sure that the arrow point to inverter. Phase number 2, we put to 28, 30 port, and phase number 3 to 31 and 32 port. And the cities are installed correct. So just these 3 cities, and our inverter will measure what's going to the grid, what's going from the grid. If we don't want to use cities, or distance from inverter to our measurement point is more than 5 meters, we have to use meter. Meter we put to our meter 485 port. We use 7 and 8 pin, 7 and 8 cable for our Ethernet cable, or we can also put this on a 7 and 8 port. So you can find a 7 and 8 number on these pins on the right and put here our meter communication cable. And the inverter is wiring, and now we can go to settings. So that's the screen of our inverter. At the top we have LED indicators, so DC, AC, and normal lighting. And on the right we have alarm. So when the alarm will show, the LED alarm show means that something is wrong with our inverter. We can check in events, we can check what's going on and what problem inverter have. If we touch any of this, so PV, inverter, grid, load, or battery, we'll go to the parameters of any of these. Of course, at the bottom we have home, settings, events, and device info. Now we'll go through all of this, so we'll make sure that you know where to do what. Okay, so we'll go here, and we have our LCD screen. So that's the home page of our inverter. If we click on this middle of the screen, we'll go to more detailed info about our inverter. We have on the left, we have parameters of inverter. On the middle will be the generator informations, or if we are in on-grid mode, we'll have the city measurements here and inverter stage, so we know inverters working on-grid, off-grid, and they have any other problem or no. And inverter temperature, of course, so does the temperature inverter have inside. If we go the time to the homepage and click on this hybrid inverter at the top, we'll have the system overview, so more information about the system. So we have the PV1 and PV2 separately, the battery informations, the smart load, EPS load, and all these informations. I don't know, you'll see the screen. No. Okay. Okay. So I will go again to this. Okay. So we start here, and we have if we click on the middle of the screen, you will see this. So on the left, inverter information, on the middle, genset information, or if we are on grid, you will see the city measurements here, and on the right, the temperature of inverter and inverter stage. Inverters on grid, off grid, it's standby or whatever. You can see here. If you click on this hybrid inverter name, you will see the system overview. So more informations, you have separate PV, PV1, PV2, you have the load, so smart load, EPS load, and non-EPS load separately, not together. If you click on any of these, so battery, PV, or grid and load, you will have something like this, so more informations about battery here, and the charts from the day, month, year, how battery working through these days. If we go to settings, so first is battery settings. First page of battery settings, we have something like this. So we have 2 battery modes we can use, so the lithium and use battery voltage mode. So if we pick lithium, all the informations we have to fill are with percentage. So the green box at the bottom, we put the shutdown percentage, low battery percentage, and the restart percentage. If we use battery voltage mode, we put this red frame, so shutdown, low battery voltage, and restart voltage. So depends what battery mode we pick, we use percentage or we use voltage, and that will go through all inverter settings. So if we use lithium, here we put lithium, here we go with percentage, but in any other page also we go with percentage. If we have use battery voltage, all the information we fill is with voltage. At the middle, so the blue frame, we have the PV information. So PV voltage maximum and PV current maximum. Make sure that the PV voltage maximum is the real maximum voltage of our PV installation. So if we have the maximum voltage 400, put 400. If it's 700, put 700. If we have 250, don't leave the 700 as default. Just make sure that this information is correct. And on the left, we have all the informations about the batteries. So if we have the BMS connection, but inverter will take this information from batteries, so we don't have to fill all these informations. But if we use any other battery without communication, lead acid battery, we have to fill this information to make sure inverter will work correct with our battery. On the right bottom, we have battery active enable. If we pick this option, inverter will try to start the battery. If it's in a shutdown, it's standby mode. So if battery give no voltage to inverter will try to start the battery, try to push any power to battery to turn it on. And on this page, that's all we have to fill. Lead battery mode is just the control number, so you don't have to change it. It will change automatically when you change the communication protocol with the battery. Second page, we have the on-grid and generator settings, how battery is working on-grid mode and how battery is working with genset. So blue frames we fill all the time. So discharge power maximum and charging current maximum we have to fill. And then we pick green or red frames, depends. If we use lithium, we fill the percentage. So the red frames, if we use battery voltage, we fill the red frames. Stop discharge state of charge. So stop discharge SOC. That means the percentage when the inverter have to stop discharging the battery. So now, for example, it's 80. So that means that inverter will stop discharging when battery will have 80%. AC charge SOC, that's the SOC when inverter charge the battery from the grid. So now it's 30. So that means that if the battery is lower than 30, inverter will charge the battery from the grid. If it's higher than 30, only from PV. General stop charge at the bottom, that's the maximum state of charge for the battery we want to charge our battery. So now it's 90, so that means inverter will charge battery to 90 and stop charging. Then if you need some power, discharge to 80 and again charge to 90. So that's the setting here. And for generator, same thing. So again stop and again start. That's the settings we have to fill when we want signal for our genset. So our inverter can send signal to the genset when to start and when to stop. If our genset support the signal, we have to fill the start and stop state of charge here. So if the battery percentage is lower than gen start SOC, inverter will send signal for genset to start. And then if the battery will go higher than stop, inverter will send signal to stop. Same of course with voltage. So start and stop voltage or stop discharge voltage for on-grid mode. The third page of battery settings is the time of use settings. So as I said, we can set 9 time ranges, and the state of charge or the battery voltage on all these times. So we pick which time, what state of charge, and then we can set we want the grid charge during these hours or we don't. We want the gen charge during these hours or we do not. This page is more important for inverter than the previous one. So if the time of use is picked, that means that inverter will work with this page, not with page number 2. So it doesn't matter what we put in page number 2 if we use time of use mode. Then we have the grid settings. So the battery settings first, then we go to grid settings. And here on the left, we have to set up the city or meter options. So we have city, we pick city and city ratio. If we have meter, we have to pick meter type and we have to pick meter address. For meter address, you have to put 005. So that's the meter address our inverter is working with meters. So 005 for meter address, type Chint or Eastern, and city or meter, so then we pick meter. Green frame is the grid settings, so maximum frequency and voltage for the grid settings, and again on the right, same maximum and minimum voltage and frequency for working with genset. The red frame, inf up rate, inf hertz rate, that's the voltage and frequency inverter have to work in off-grid mode. In on-grid, of course, it will follow the grid, but in off-grid mode, it will use this setting. So inf up rate means that now for these settings, for example, will be 220 volts for off-grid mode. And the white is the grid power maximum. So now it's 15. So now it's 15 kilowatt maximum power, but we also have the grid limitation enable. So if it's not checked, if it's not picked, this grid limitation is not working. We have to pick this box, check this box, then this grid limitation is on, and the inverter will limit the power of taken from the grid to this. So now for 15 kilowatts. Second page, we set up the smart load, gen set or AC couple. So that's the gen port mode. So we on the left top we have smart load, AC coupling, or generator. And if we pick generator, we have to fill these informations at the bottom. So gen mode, gen power maximum, and we want signal to start generator or we don't. For the gen mode, we have mode 1 and 2. Basically, mode 2 is more used in genset when the power of genset is lower than inverter power, and if it's higher than inverter power, we have to use mode 1. But you have to check this on site. So if mode 2 is not working, try to check with mode 1. It depends of genset which we use. So check mode 1 and mode 2. One of these should work. For the smart load, we fill all the blue frame. So we have to fill the battery state of charge on and off when we want to use this smart load. We have to fill the smart power in watts. That smart power means the minimum power from PV panels we want to start the smart load. So now it's 600. So if the PV panels give minimum 600 watts, the smart load will start. So state of charge for battery is 90 and 85. So it will work between these two values. And then we have on-grid always on. That means that on-grid smart load will be always on. And on the left, we have only battery enabled. So that means that always when the battery is enabled, inverter will power the smart load. And for the AC coupling, we have the green frame. So we have like the state of charge for start and stop, and AC couple frequency on the left. Third page, we have to pick the safety standard according to our safety standard in our country. And we have the safety time enable box. That means inverter will extend the time before it will reconnect to the grid. So if we don't want inverter to reconnect as fast as it can, we can extend this time and pick this safety time enable. All the other settings on this page related to reactive power. So we can set this reactive power some ways. We can pick the way in reactive power type. So reactive power set directly or power factor, or we can use the Q curve to set this. So these settings we can fill here. Third settings are professional settings. So here we set up the working mode of inverter on the left. On the right, we have the grid and gen charge enable. So we allow the grid charge or we allow the gen charge or don't. And at the bottom, we have the parallel settings. So we put how many units total we have parallel connected and inverter address. So master is number 1. Then we go with any second number. So 1, 3, 5, 7, etc. So any inverter take 2 addresses. So first one will be 1, it's master, and 3, 5, and so on. And if we're talking about working modes, we have 3 working modes. So we'll start with cell first. So cell first means that inverter will sell all energy from solar panels and from the battery up to the value we put on this yellow frame. So now it's 2 kilowatts, 2000 watts. So inverter will try to sell 2000 watts. If cannot do this from solar panels, we'll try to sell also from the battery. That's basically the mode very similar to on-grid inverter. So what I have to sell. Second mode is zero export to grid port. That means that inverter will stop power on the grid port of inverter. So don't support the on-grid home load and don't sell to the grid. So inverter will charge the battery, will secure the backup load, the smart load, but do not support the on-grid home load, do not support the grid. But we can pick the solar cell. Solar cell means that if I have enough power to support the backup load, charge the battery, do the smart load, etc., I can sell. So I can put this power to the grid port. So if I have more than enough, I can put this to the grid port. So I will go with the on-grid home load and sell to the grid. That's zero export to grid port. And third option is zero export to city. To pick this option, we have to pick, we have city or meter. If we have known in our grid settings, if there is known picked, we cannot choose this option. So if you cannot choose this option in any installation, just check if you picked, you have city or you have meter, because if you don't have any of this, you cannot check this option. And that means that inverter will stop power on a city. So we'll try to have zero on city measurement. So we'll secure the backup load, we'll charge the battery, we'll also secure the on-grid home load. And then similar as with the zero export to grid port, we have the solar cell option. So if I have more than enough, I can sell. So if I secure backup load, on-grid home load, charge the battery with maximum power, or battery is charged to fully charged, I can sell to the grid. We have also the value, like now on a yellow frame is 100, zero export power in watts. That's the power inverter will always buy from the grid, because the load, on-grid home load, is always changing. So inverter will try to produce as much energy as on-grid home loads need. But if we don't want to sell any during these changes, we have to put this some power to buy all the time. That inverter will not sell. So any small changes, some watts change all the time, inverter will always buy. And if we can sell, we can put zero, then inverter will just sell these watts and buy sometimes and sell and buy. So that's the third option. And of course the solar cell if we want to sell. For system settings, so here we have the system data and time. At the left bottom, we have the battery communication settings. So we have BMS address for BMS communication protocol and BMS port. So for BMS address, if we use RS485, we put 001. If we use CAN, it's 000. For BMS port, we pick the brand, which battery we use basically, with protocol we use. So it's a Felicity or it's Chisage or it's Pylon Tech, etc. For our batteries, so if you have our batteries, you will use the Pylon Tech protocol. We use Pylon Tech protocol, so you pick Pylon. So for our batteries, it will be 001 RS485 and Pylon, or 000 CAN and Pylon. That's for our batteries. Battery share enable, that's for parallel connection. That's information for inverter, that it's not the only inverter that this inverter is not the only one who's charging the battery. So if we parallel inverters and parallel batteries, inverter will know that it's not the only one who's charging this battery. And battery packs, we put how many battery packs we have. On the right bottom, we have the firmware, actual firmware, what firmware we have. So 3 packages, INF, DC, and DISP. And at the top, only thing we need to know is that if we want to update our firmware, we have to pick this update EN option. So if it's not picked, inverter will not allow to update. So if we want to update, just make sure that this option is checked. Of course, if we pick any option, we have to go with set, then put the password and accept this password, and inverter will change the settings. That's about settings. Then we have the events. So we have the all events record here, history of events and current events. When the event is important, when any warning on fault is important, the alarm LED will show. So if the alarm LED is off, that means that any of these warnings, any of these faults are from history, or they are not of effect of inverter working. So for example, if inverter is working off grid, inverter will show the warning that have problem with synchronization with the grid. So that's obvious, like it will have problem because there is no grid. So the warning will show, but the alarm will be turned off. That means that inverter know that in off-grid mode, he don't care about synchronization. But for the record, we'll have the warning here. And device info. So we have the serial number of our inverter, battery communication settings, firmware, and protocol and device model. So that's the basic informations of our inverter. Now I want to tell you a few things about parallel communication, about parallel connection for our inverters. So if we want to connect inverters parallel, first thing we have to connect them with two cables. So one is Ethernet cable and the second one is CAN. Thank you. CAN parallel cable. We have to connect both. Inverter will only work correct when we connect both. So Ethernet cable we connect in this RJ45 port. So parallel A and parallel B. Basically, it doesn't matter if we connect it from A to B, from A to B, or the other way. And of course, to secure from any disconnections, we can put the ring. So we can connect first with all the other and the last with the first. Yeah, so we close the ring and have a backup communication way for our inverter. Same with our RS485 cable. So we connected in port 1, 2, and 3 and 4 for our inverter. And the same, we go from first to second to third to the last, and from the last to the first inverter to make sure that this communication, we have the backup for this communication. And then we have the switches on our inverter, K6, K7, and K8 for parallel communication. For first and for the last inverter, we go with K7 on. So K7 is on, K6 and K8 is off. And all the other inverters, so for the first and last K7, for all the other inverters, all three switches are off. So we have three inverters. That means that first and third will be K7 on, and the second inverter K7 off. If we have more inverters, all between the first and the last will have all the switches off. So that things we have to connect, and we have to check with under our communication cover. And then we go to settings. So we go to professional settings, and we have to fill this setting. So for three inverters, we will go with parallel unit total number 3. In all three inverters will be the same number, so it will be 3. And inverter address, as I said, each inverter take 2 addresses. So master will be 1, then slave number 2 will be inverter address 3, and then 5. If we will connect another one, will be 7, etc. So we have to fill also these informations, and always inverter address number 1, that's master inverter. And on this inverter, we have to choose all the settings. This inverter will manage all the installation. So next thing we have to do, go to grid settings, and we have to pick the measurement. So for the master, we pick the real measurement. So if we have cities, we pick cities. If we have meter, we pick meter. So for the master, we pick what we have. So we have city, meter. For the slave inverters, we have to pick cities all the time. So for any slave inverter, we go to city, and city. And all these inverters have to have this information filled. If we have none here, it will not work correct. The measurement will be not correct. So for master, true information. For slaves, city. And our inverters are connected parallel. We can change any settings in master, and installation should work correct. For the batteries parallel connection. For Moon series, we connect first battery with our inverter. So we use this port named CAN on our battery. And then from first battery to second battery, we use these ports RS485. So we pick from first one to the second one, for the second one to the third one, and so on. And then if we connect these cables, of course, power cables, we have to parallel. We have to use any bus bar for positive and negative power cables and two inverters. And if we connect this correctly, then we have to pick to do the deep switches settings correct. So on the master, so on the left, we pick how many batteries we connect parallel. So if we have two batteries, the number 6 switch will be on, all the other off. If we have 3 batteries, number 5 and 6. If we have 4, number 7. All the others are in our user manual. So I just pick here these 4. But if you want to connect more than 4, all these informations you will have in user manual. You have user manual with batteries, so that should be easy. And for slaves, same. I pick only 4. All the other are in user manual. So if we have 2 batteries, we have to go with number 2 switch on, all the others are off. So if we connect 3 batteries parallel, for master we'll go with number 5 and 6 on, and for the slave number 1, so the first slave battery, will go with number 2 on, and for slave number 3 we'll go with number 2 and 3 on. And that's the dip switches settings done, and these batteries will walk parallel. For the CE4 800 and 200, we do basically the connection, the communication cables going very similar. So from inverter to first battery, we go with this CAN port, and then we'll go from CAN in to CAN out, from CAN in to CAN out to the end. So all these batteries, of course, power cables parallel, and then because these batteries don't have deep switches, we have to add this address manually. So we have to use the JBD software, go to config, and this yellow frame on the middle, we have the BMS, so we have to put the address manually. So for the battery number 1, we go with number 1 and set. For battery number 2, we go with 2 and set. So master, of course, number 1, and the other batteries 2, 3, 4. In order, we connect them to this master. Okay, I think I said everything I want to say about how to connect our inverters, how to connect Mars to the grid, to the load, how to connect batteries to inverter, and how to make the parallel connection. Now, if you have any questions, just ask and I will try to answer all of them. I have to open the chat. Okay. Good morning. Great. Good morning. Hello. Greetings from Scotland. Greetings to Scotland. Okay. Jakie obciążenie możemy podłączyć pod EPS load? Okay. So the question is how much load we can connect to EPS load. So for the EPS load, we can connect a maximum around 18 kilowatts. So it's 26 amps. We can connect 26 amps to the EPS load in on-grid mode, of course, because inverter will take this from the grid if you need. But for off-grid mode, it will go with inverter power. So basically, if we want to support all the EPS load all the time, so it can be maximum inverter power. So for Mars 10 will be 10 kilowatts for EPS load.
Czy cały home możemy podnieść odpisać?
Czy cały home load możemy podłączyć pod EPS load? Tak. The question is if we can connect all the home load to EPS load. Yes, we can connect all the home load to EPS load, so we will have all the home load as backup. So we'll have this on-grid and off-grid. If we have enough power, yeah, so if we don't go more than 18 kilowatts, we can connect it that way. No, we cannot use any other protocol than Pylontech for now. And for our old batteries, we have the Chisage protocol. So for old batteries, for CE 4800 and 200, like the version 1, with the connectors at the bottom, so they are different, we can use Chisage. For the new batteries, all the batteries basically we have now, we use Pylon. What is the maximum load of the smart locking on the Mars 14? To Mars 14 is 14 kilowatt maximum for the smart load also. What means the number in lead battery mode? Number in lead battery mode is just the control number. So it will change when you change the communication protocol, when you change from CAN to RS485, or you change the protocol from Pylon to Felicity. This number will change, but it's automatically, and that's only like for the service. Yeah, so we know what protocol inverter use, but it's just for the record, so no need to change this number. How about the neutral treatment when in off-grid mode? About neutral treatment, now we add the option for our inverter to do this. So now we have to go to the settings, and we can pick the option, and it will go automatically. So now it's okay. So now we can do the neutral treatment like in one pick. How does it work with an asymmetrical three-phase load? Does the inverter balance the consumption across the three-phase? Yes, basically yes. So if we have any unbalanced load, inverter will try to balance the consumption. So and basically it's working automatically, and you cannot change it. So inverter balance the consumption across the three phases. Yes. Okay, the question is if we need any special automatization to change from backup to regular power. No, we don't need. If you put something in a backup load, all this backup load will work in on-grid and off-grid all the time. So basically, if you put any load to backup load to this load port, inverter will take power from the grid, from the battery, from PV, and when the grid is off, inverter will switch to off-grid and still power this load. So no need to add any other devices. So all inside inverter, or inverter will manage this by himself. Smart load fatigue and backup. Yes, but you have to remember that you cannot put the smart load 14 kilowatts and the backup 14 kilowatts together, because you have 28 kilowatts to power. So we cannot do this. So it have to sum up to the power of inverter. Yeah. So for 14 kilowatt inverter, the sum from the backup load and smart load have to be 14. Cannot go higher than this. Is it possible to manually charge the battery without putting a schedule? Yes, the easiest way is to use the time of use mode. Just pick the hours and inverter will charge the battery. So put 100 in for now. Now it's like almost 11. So from 10 to 12, for example, I will put 100% state of charge, and inverter will charge to 100. The other way, just change the settings on the page 2 of the battery. So go with discharge 200 and AC charge 200. So inverter will charge from the battery from the grid. Chisage order why from technical point? Freaky points. Okay, Maciej. I can invite you here. First of all, we can connect 20 parallel in off grid, 6 in on grid mode, so we can do the bigger installation from our inverter. Second thing, 5 kilowatt per phase unbalanced output. So for up to Mars 10, it's more than any other brand. For most of brands, it's 50% of the rated power. Third point, me and our technical staff, so we can help you all the time. And if you need this, I think that's a good key point. I would like to be your partner in the market. How we can start to cooperate? You just have to contact with us. Leave the contact here, or you can message or email us at bureau@chisage.com, and we'll contact you and we'll speak about our partnership. If grid voltage goes lower, do an inverter switch on by remote, or just goes safety protection? If we set we're losing warranty. So if the grid voltage goes lower than 200, it depends. So inverter will go to off grid, so switch to battery when the voltage will be lower than we set up in a grid settings, or it's set by safety standard. So if the safety standard, all the grid settings say that the 200 volts is the minimum volts, if grid will go lower than this, inverter will switch to battery mode, so we'll switch to off-grid mode. It's not safety, like it will not go to safety protection. If we set to 170, are we losing warranty? Basically, inverter will not give you permission to set less than it can be. So for Mars is 165 volts, and you cannot go lower than this. You cannot set settings lower than this, so you will not lose the warranty if inverter approve these settings. That's okay. Często tak, że wejście loadu obsługuje wyłącznie miał a zamierza obciążenie. Przed chwilą mowa była, że można całe obciążenie. Yes and no. Okay, so for the load we can put all the power of inverter. So yes, for 14 kilowatt Mars we can put 14 kilowatt load. For 5 kilowatt is just unbalanced load, so you can have maximum 5 kilowatt per phase. So you can put 5 on phase number 1 and 0 for phase number 2 and 3, and the inverter will power this maximum to this 5 kilowatt. But for the whole load we can go with 14 if we have Mars 14. So for Mars 10, of course, it will be 10 kilowatt. So all inverter power to the load port, but maximum 5 kilowatt per each phase, unbalanced output. These chargers have a spare part. Of course, we have spare parts here in Europe, in Poland. We can change any parts. We have any parts for you if you need anything. So yes, we have a spare parts here. I will just say more about this load, because I see a lot of questions about it. So for the load, for the backup load, we can put all the power of inverter. Yeah, so for Mars 10 we can put 10, but then if we have one phase load more than 5 kilowatts, inverter will just give 5 kilowatts for this phase. So maximum 5 kilowatt per phase, and all the phases have to sum up to rated power of inverter. May you secure my first installation with Chisage product? Of course we can. If this webinar and all our YouTube videos will be not enough, of course you can contact us. The email is below, so tech.support@chisage.com. So you can email us at this email address, and we'll answer all your questions. So as is right on the screen, you can ask here on the chat, but then this video will stay on YouTube, of course. So if you have any questions later, you just can email at this address, and we will answer all your questions. Is it planned to release low voltage inverter power more than 14 kilowatts? For now, we don't do this. For now, we are launching the high voltage inverter Merc. That will be like very soon. We'll have this in Europe like almost now. So we don't do low voltage inverter right now, but who knows in the future. Temp-co enable. What it means? That's the temperature coefficient. That's for lead acid batteries. So the coefficient index for temperature and voltage. Basically, you don't have to change this if you don't know what this means. So it's set for -3 milliwatts per degrees, and that's okay for the default. 14 kilowatt, you can secure 21 kilowatt of peak. Yes, 150% unbalanced output, so we can secure something like this. When will be Merc high voltage inverter in Poland? Don't know like the specific date. Soon means that we are doing the transportation, dealing with transportation now. So should be like almost now. However, you can explain more what the solution to with 30 kilowatt and 60 kilowatt hours. Okay, so if you can, for the parallel, of course, you can connect inverters parallel, you can connect batteries parallel, and you can make basically the bigger installation. So you connect 5 Marses 10 kilowatt, so you will have installation for 50 kilowatt. So you connect 5 Marses for 50 kilowatt, and you can connect 6 kilowatt hour batteries. So you can, for example, connect 6 batteries like Moon 10, or you can use Moon 16, for example. We will have 4, and you will also secure the 60 kilowatt. 60 kilowatt hour battery. So parallel connection, if you connect this like all batteries and all inverters together, it means that we'll have one big installation. So it will work like one inverter with 50 kilowatt and one battery with 60 kilowatt hour capacity. Joe with bulk, yeah. Thank you, Will. Yeah, so small quantities April for Merck, yeah, that's for Merck, and for bulk orders June. May also, of course, we'll do much more videos on our YouTube channel than it's now. So of course there will be much more videos for parallel connection also. Yes, we have the solutions for 100 kilowatt and 215 kilowatt hour. Its name is Polaris 100. So we have the Polaris, and basically it's ready now with all the certifications. So if you need inverters with all in one, basically all in one with 100 kilowatt and 215 kilowatt hour, it's ready. W18 grid high frequency warning. This shown often what to do. Basically, it means that the frequency from the grid is too high. So basically, the first thing is to check if it's correct. So if the grid frequency from the grid is really too high, because inverter will manage, like, will show this warning anytime the frequency will go higher for any time. So from our platform or for mobile app, you will see the 5 minutes average. So for the 5 minute average For example, the grid frequency will be 50, but in 1 minute it will be higher than maximum frequency. So firstly, check if this frequency is okay, and also you have to check if in your settings, so you have to check settings, grid settings, if the maximum frequency is set up correctly. So you have to check the grid settings, maximum frequency, what's the value here, and check if really the grid frequency is higher than it should be. I would like to cooperate on name, not sure if I made, and his words are, and guess that technology is also efficient as manager and the team. Yeah, this technology is the same efficient as we are here with our manager, of course. Well, on cabinet support, off grid, and yeah, this cabinet, yeah, of course, well, yeah, that's true. So the cabinet, 100 kilowatts, 250 kilowatt hour, is also hybrid. So it's also support on and off grid mode. Yes, that's the same as our hybrid inverters. What happens if one of the grid phases falls with the Mars will work well in terms of charging the battery and spiral? If one of the grid phases fails, Mars will go to off grid. Will go to off grid mode. So we'll charge, we'll supply the load from the battery and from PV panels. About access in other markets. In which markets we can sell? We are in whole Europe, so everywhere in the Europe we are looking for partners and for distributors. How about Nordic? Same. Same with Nordic countries. Like if you want to work with us, if you want to be our partner, just have to message us, and we are open to discuss and then find a way to work together. When I have the chance to probably know. Almost for Denmark, we are like in the process for the certification right now, so should be finished soon. And for Norway, we'll start it later. But if we have anyone to cooperate in Norway, of course we can do this faster if we have any customer here. Yeah, and now you have the emails in chat, so take that support for us. So if you have any technical questions, go with this email, or if you have any questions with our cooperation, partnership, etc., you can write directly to Maciej, so maciej.c@chisage.com. So all the positive lists and wireless you already have. Not for all the countries. Like I said, for Denmark, we are in progress. For Norway, probably later. For now, we don't have. For any other countries, for Slovakia, we are in progress. For Czech, we basically almost have. For Romania, for Hungary, for any other countries. For Italy, we have certification. So depends. We are working on it all the time. So things change fast. Is there a way to change the BMS settings to increase the charging current? No, you cannot change the settings. So you cannot increase the charging current at these low temperatures. Of course, the temperatures below 10 degrees, batteries start to decrease this charging current very much. But we cannot make it bigger because like this charging current is lower to secure to save the seals. Can you connect at three-phase grid, one-phase inverter for security? We cannot connect three one-phase inverters to the three-phase grid yet. We are working on it, but for now it's not possible. But maybe in the near future it will be. Any thoughts on enclosures that could keep the batteries warm? Basically, I don't know. I think one of the ways to add a small AC conditioner for any smart AC conditioner, which will take like plus 10 degrees on the room. So that's one way I think to do this. And if it's a big room, you can build a small wall to secure this cheat from going outside. But we don't have any solution to warm the batteries. How BMS and batteries in winter, in which temperature battery will stop working? Stop working in minus 20 degrees Celsius. So it stopped working, but it will charge in more than 0 degrees. So up to 0 degrees is charging. Like below 0 is not charging, but this charge up to minus 20. Of course, the charging current will decrease, and the discharging current also decrease when the temperature going low. And if we go the other way, the same way, if we speaking about temperature going higher, so in a higher temperature also the charging current go high, charging and discharging current will go lower. In a country where the grid isn't stable, where all the three phases don't usually fire at the same time, might as well always go back to over mode if yes, what is possible. Yes, in the countries where the grid isn't stable and we don't have three phase or like all the time, inverter will go to off grid mode, basically like all this time.